Thank you very much, UK. Okay. So thank you very much for this invitation and for the opportunity to talk about NFC today. This is, I must say, really a cool place. So if somebody would have asked me, so please, Stefan, tell us how you imagine it's a really cool hackerspace, how it would look like, I would have probably described it like this. And yeah, so the topic I'm talking about today is NFC caught between hype and compromise. It looks a lot about philosophical wisecracking, but it is not. So I will talk a lot about the technology itself, but also many of you may be interested, you know, like NFC is around for many, many years now. Why didn't it really make its way into phones? And I think this is also something that we have to talk about. Well, the first time I was encountered with NFC, I think it was in 2006, and I was at the so-called Nokia Technology Day. That was some kind of a Nokia internal technology show, and I have to say I was really excited when I've seen it, because it was not just a feature; it was a new technology, and it was a technology that had the potential to really change the way we interact with phones, and also how we use phones to interact with the environment. And it seemed to me these days that NFC is some kind of the missing item to implement the Internet of Things, because you could have an NFC tag being glued on devices, and also the usage paradigm that I interact with somebody that I just touch his phone was very appealing. And others were kind of starting to have dollars in their eyes, because even at that time it was clear that payment was a big topic. But then it was 2007 and 2008 and nothing happened. Then there was one or the other trial, then it became 2009, 2010, 2011, and finally there were two phones out in 2011. It was the Nokia C6 and the, or is it C7? C7, and the Nexus S. But even for those phones, there was NFC inside and partly well implemented, but still some use cases have not been working. But I think we are slowly getting there. So am I telling you that NFC has failed? No, I'm not telling you, but I think at the end of this talk, when you know more about NFC and about the reason, you may decide for yourself whether it will fail or whether will it succeed. I think it succeeds. Nothing is really sure on this world. The only thing that is sure is that we will have some very nice dinner at 8:15. Okay, so the content is, so I will just tell a little bit about my employer, the company I work for. Then I will tell what NFC is and what NFC is not, because there's a lot of confusion around. Then I will go through the NFC operating mode and make a deep dive into really the use cases, the technology, and the stacks involved. Then a few words about if you would like to develop NFC stuff. I will talk about two options, like the OpenNFC stack that is published on OpenNFC.org, and probably you know better than myself what to do with Android. Then some hardware implementation, so if you dismantle some of the phones, how that would look like. And then finally some analysis. So will NFC take off? And yes, why didn't it happen already? So a couple of words about Symphony Teleca. This company is really young. It is probably only 3 months old or so. And it's a merger of Symphony Services and Teleca. Both of the companies formerly belong to the Symphony Group. Symphony Services is a company which had about 4,000 employees, and with a headquarter in Palo Alto. And Teleca was a company with about 2,000 employees with a headquarter in Sweden. Symphony Services was very much working in the enterprise area, so they were serving the big independent software providers like Microsoft, Oracle, SAP, and so on. They have been dealing with rich analytics and telecoms expense management. Amazon Cloud is their customer. While Teleca, I was in Teleca, we came more from the embedded side. So starting from mobile phone development, going to consumer electronics, and also now automotive infotainment, but also slowly going into the direction of services, end-to-end services, white label, app stores, and so on. And it was felt to be a good idea to merge these companies. They have a pretty complementary portfolio, but as we know, the user interface also for enterprise applications will be more and more mobile devices, and that is a very interesting challenge. And now with Felica on the embedded devices side and with Symphony on the enterprise side, we believe that we can start playing an important role in that. So we have, as I said, 6,000 employees, China, Europe, India, Japan, South America, US. I work in an office in Bochum, and yeah, so far about, this is the advertisement block, and it's already ended. So what, no, not yet. So what we do in NFC, so we have executed a couple of projects in USA, Germany, Poland, and India, mostly around stack integration, stack adaptation, stack testing. Customers have been device makers and semiconductor companies. So some reference projects were integration and adaptation of stacks for Windows 7, Windows Phone 7, Android, WebOS, Linux, then adaptation of stack A to component B, and then test automation and testing, and also some demo applications. In the US, we are involved in the payment infrastructure development of a big kind of payment service company over there. So, introduction, what NFC is and what is it not. So, my talk is subdivided in different sections, and at any time, if you have a question or if you have a comment or if you think I'm telling bullshit, please raise your fingers, and if I see this, despite of this spot that is currently grilling me, I will be happy to answer your question. So RFID, I think you all know what RFID is, and this is basically about having wireless memory tagged to some devices. RFID comes from radio frequency identification, and the initial purpose was to identify items from a distance, and the applications are, of course, ticketing, as you know, ticketing, then we have logistics, then access, also for toll gates, very important, theft protection, payment, product safety, and also animal identification. And very interestingly, there was, I think, in the IEEE transactions on software, somebody, or transactions on pervasive computing, how to work, somebody who really implanted this in his hand and lived with it a couple of months and tried to find out whether there are benefits to having an RFID tag embedded in the body, so some special type of animal identification. There is basically two types of RFID. One type of RFID is a backscatter RFID, and this kind of RFID you would recognize when you take a look at the tag. The tag is basically nothing but a dipole antenna with some electronics here. And if I zoom into this electronics, I see this kind of circuitry. So how backscatter RFID works is that there's really a reader that is radiating an electromagnetic field. It is really working with wave propagation. And then there's an antenna on the tag, which is here. And there's some digital logic, or sometimes even a little microcontroller. And the first thing you have to do is you have to power this microcontroller, and that's why you have here a rectifier. And this would power this microprocessor, or this logic. And what this logic does, it has a connection to this little field effect transistor, which is basically nothing but a variable resistor. And it would then kind of modulate the drain source resistance of this FET, which would then result in a periodic detuning of this antenna. And that has an impact on the power that is scattered back to the reader. So you can imagine if you drive down an alley with your car and you have your cars turned down, and you have trees on the left and the right that reflect the motor engine, you get some voice like, and that is some kind of acoustic backscatter RFID, and this is the whole thing is just working with electromagnetic wave propagation. The ranges you can achieve with this is about 3 meters for entirely passive tags that don't have their own power, but everybody of you has probably been have had some active RFID tag in some other country where you rented a car, where you have active RFID tags, and these have ranges up to 15 meters. So this is one type of RFID, but this is not NFC. Don't confuse it with NFC. And I believe this kind of tags you would use, for example, in logistics. And when years back, Metro and Walmart tried to label their stuff, and there was a big outcry that there's this transparent shopper now, and everybody knows what I have in my bag. This was this kind of, let's say, evil RFID. So the good RFID is the inductive coupling RFID. It works very similar. So you have also, first of all, you would recognize inductive coupling RFID because it has not a dipole antenna, but it has a coil type antenna. You see, it looks like this. Probably you can see it. And what happens is that the reader would have the same kind of antenna, and you move them together. You have something like a transformer. And the transformer, the energy is transmitted via inductive coupling, not via wave propagation. And you can imagine this only works for a very small distance. If you have it embedded in a device, you would typically even have to touch the other device, and it would work at maximum at a distance of 5 centimeters. So eavesdropping of this kind of RFID is very difficult. You need some very heavy equipment, and you would probably notice if somebody would be next to you that would kind of eavesdrop your communication. The electronic looks very similar, so you have a rectifier to power your chip. You have again this field effect transistor, and you would detune the field with your secondary coil. Then you would see kind of a load modulation, the primary coil, and through band pass and a demodulator, you can finally detect the signal. Okay, so this was inductive coupling RFID, but it's not yet NFC. So there's RFID, there's inductive coupling RFID. Within inductive coupling RFID, you have techniques that work exclusively at a frequency of 13.56 megahertz. This is still not NFC. There's a selection of technologies within this 13.56 megahertz that have been selected because all the technologies have been out there when the NFC forum was founded. And there is another operating mode added that is peer-to-peer. A tag is nothing like a wireless memory, so as a one-way communication way, you read what is in the memory, but peer-to-peer you can also have really bidirectional communication. And the selection of the technology that went into this NFC bucket is done by the NFC forum. The NFC forum was founded 2004, and here you have all the typical suspects that would be interested in mobile payment and semiconductor manufacturing. So it's banks, it's credit card issuers, it's device makers, and maybe one of the most important companies is NXP, former Philips, who had big stakes in inventing all these technologies. On the other hand, very often forgotten, and you hear not so often about it, is Felica, but Felica is also some kind of NFC technology, but it's not called NFC. Even Felica people don't call their technology NFC, they call it Felica. And also in 2004, there was a company founded, Felica Networks Incorporated, from Sony as a semiconductor, then NTT Docomo as the biggest Japanese operator, and East Japan Railway, who wanted to have RFID as a ticketing system. They founded Mobile Felica, and Mobile Felica, they put NFC, Felica type NFC into their mobile phone. So far about NFC. So now you know the difference between NFC and RFID. So NFC is RFID, but RFID is not NFC. And Felica is some kind of NFC, but not really. So let's go a step back and see what is NFC NFC good for? Please ask questions. So if there's anything, if you have any questions, don't hesitate to ask. So the main purpose of NFC was in the beginning was also identification. So the less sophisticated tag is just a piece of wireless memory. If you want to do something more sophisticated, you need something like a contactless credit card. You have a smart card which has really a processor on it, like a 16-bit. It has bigger memory. It has a smart card operating system, and today it typically also runs Java. And then if you go a step further, you have something like a connected smart card. So if you use your phone as a smart card, then this smart card can even connect to the cellular network. Of course, it can more. It can also read and write tags. So back to the NFC Forum. The NFC Forum, as I said, was founded in 2004. And the main mission of the NFC Forum is to encourage and to promote the creation of mobile devices that could interact with the NFC ecosystem that was already out there, but also to encourage new use cases with these mobile phones. And yes, the main driver behind this was, well, there is an ecosystem out there of contactless readers, and why not making the phone part of this and enable new use cases, but also with the peer-to-peer communication, enable NFC use cases between devices, let alone smart cards and so on. Okay, that's the NFC Forum. Any questions so far? Okay. Then let's go a step further to NFC operating modes and use cases. In NFC, there is 3 operating modes. Operating mode number 1 is to use your phone as a reader or writer. You simply read something that is stored on a tag, and whatever is stored on this tag would invoke some action that is coded in your phone, or you write on a tag in order to have this tag for later use. Here you see one very famous example is the smart poster, where you probably would like to buy a ticket for an event that is advertised on a poster. Next operating mode is peer-to-peer, which is simply about putting 2 phones together and transmitting information, and then also invoke context-sensitive actions that are dependent on what applications are currently running. And then card emulation, which is simply using your phone as a credit card. When you take all these operating modes, you can roughly identify 4 groups of use cases that you can do with it. First of all, first use case is the service invocation. In the service invocation, you have as actors the phone as a reader or writer, a tag, and in many cases also an operator. So what you do is you read the tag, and whatever is stored on the tag, for example, a URL, a phone number, an SMS, would invoke an action like, for example, opening the browser with the particular URL. So pretty straightforward. What kind of tags are supported in NFC Forum? As I said, many of the technologies have been out there, so the NFC Forum had to make a selection of technologies. So NFC Forum defines 4 tag types, and of the 4 tag types, it also defines the way how you store information, like, for example, URLs on these tag types. And the tag types are, in the compatible product of these tag types are InnoVision Topaz for the tag type number 1, then NXP MyFair Ultralight for number 2, then tribute to Sony, who was also one of the founders of the NFC Forum, is to include the tag type number 3, which is the Felica Insecure tab. And the tag type number 4 is the tag type which is used for mobile payments. That means for smart cards. Tag types 1 and 2, I think, except the Ultralight C, which has some security on it, they are insecure and they store little information, something typically below 100 bytes. You can have tags of these types which store more than a kilobyte, but the typical use is to have very inexpensive tags for like one-way tickets and these kind of things. NFC Forum Type 3 tag is a little bit more sophisticated. It has some basic file system. Also, if it's not called file system, they use it services, and they can store a certain amount of data per service. So it has a means to organize the data. And finally, the NFC Forum Type 4 tag is not really just a wireless memory. It is a computer. So it has a processor, has crypto algorithms, has memory. It runs an operating system. And typical products for these is NXP Desfire and NXP Smart MX. With the JCOP operating system, that is NXP's proprietary Java operating system. Any questions so far? Okay. A common misunderstanding is very often people come and say, well, NFC Forum supports Felica, but that is a misunderstanding, because when you talk about Felica also using a Felica phone as a ticket or as a smart card, then this cannot be supported by the NFC Forum Tag 3, because this is only more or less a little better wireless memory, but it's not a smart card type of tag. So you cannot do any kind of card emulation with it. Now let's take a look at the protocols. Don't get confused with this. This is just like for later reference. I just talk a little bit about this stack. So this is the whole stack. It's a little bit simplified, but to give a rough understanding, the blue stuff is just glue specifications by the NFC Forum, and all the yellow stuff has been existed before. And if I look at the tag standards, then the relevant part of the stack looks like this. And yeah, it's a little bit strange because you have 3 different stacks to read wireless memory. It's like you get a Swiss Army pocket knife, and you try out what's in there, and you find 4 blades, maybe a long blade, a small blade, a thick blade. But why do you need a pocket knife with 4 blades? And the answer of this is probably that the manufacturer of this pocket knife is a joint venture of 4 different companies. So on the bottom of this protocol stacks, in most cases you have ISO 14443 type 3. This is something you should remember, because this is the mother of all NFC based standards, let alone this Felica standard, and a lot of standards have been based on this. ISO 14443 consists out of 4 specifications. Layer 1 is just the layout of the plastic cards, because it was basically the standard to standardize contactless proximity cards. Type 2 is the layer 2 is the electrical interfaces. Layer 3 has to do with the tag discovery, tag identification, also tag collision detection, or anti-collision. So if you put several tags in the field, there must be a mechanism to select one of these tags. And then the layer 4 is basically the layer that is kind of a wrapper layer to adapt the wireless tag to the standard protocols to communicate with smart cards. For example, the SIM card in the phone is also a smart card, and it connects and communicates with a host over a standard that is called 7816. And so this ISO 14443 is just a kind of a glue layer between the lower level protocols and this ISO 17816. So let's take a look. Type 1 and 2, they are both based on this ISO 14443. So if you detected the stack and the stack is fired up to some degree, then you have to decide what kind of tag is behind it. So there's in the stack there's some identification mechanism, and then one time the MIFA ultralight stack is started up, and otherwise the Topaz stack is fired up. For the Type 3, you have an entirely different modulation and radio, which is based on this Japanese standard, which was also invented by Sony. And on top of that, again, you have this NDEF record which stores the information. We will later see what NDEF exactly is. And since this is not enough confusion for ISO 14443, there's also 2 types, Type A and Type B. Type B has, I believe, once been cooked up by a French consortium, and hopefully I'm not telling something wrong. I think it was to circumvent some licensing problems with Type A, so they wanted to do something on their own. Because I don't think that there is, they're really, they're not complementary. They're doing basically the same thing, but just in another way. So that's the different protocol stacks. Any questions so far? Okay. So what is NF? NF, you say, on what is common to all of this, that they store the information in terms of an NF record. An NF record is something very simple. It's not even a protocol. It's just a content format. So an NF message consists of several records. Each record has a header and a payload, and the header has an identifier saying, well, this is a record of this and that type, and a length and a type field. And you can, for your own application, you can cook up your own RTD record type specification, but a couple of them are already specified by the NFC forum for you, and there will be more added later. For example, there's an NFC URI RTD that tells you how to store a URI in a record, and then there's a smart poster RTD where you can store URLs, SMS, and so on. So you can imagine that there's a couple of these specifications, and also that it's useful to define a common message for these. So since there's all these different technologies, so what does the phone do to don't get confused with all the tag types that could, in theory, be kind of positioned below the phone, and also the fact that the phone itself should act as a credit card. So what happens is that most of the time, for example, here 300 milliseconds, the phone, the NFC modem, is simply listening for an external field. That means in this 300 milliseconds, the phone is behaving as a credit card, and would answer as a credit card to a remote credit card reader or a smart card reader. And then, of course, you have different technologies. You have ISO 14443A, and that is polled, for example, in the first 5 milliseconds, and if there's no answer, then you poll for 14443 type B, which is a different PHY, a different physical layer, so you have to do it separately. Then, if you don't find anything, you go to Felica, and if you don't find anything, you go again and for these 300 milliseconds. Yeah, this is a little compromise between performance and power consumption. So, of course, NFC pulls power, and it's considerable. And if you have the NFC modem on all the time, then it can empty your battery. I mean, faster as if you would not have it on, and the technology is improving all the time. Of course, it consumes least power if in this reader mode. But if you have it kind of, if this 300 milliseconds turn into 400, 500 milliseconds, you don't anymore have the feeling that you would touch something. It would be more kind of a hold type user interaction. So the period cannot be too long. If it is too short, then you pull too often, then you would draw more power. So this is kind of a compromise. Yes?
Can you compare it to something else is needed in a phone? Another service or another part of the
in terms of power consumption?
Yes.
To be honest, I had some overview a couple of years ago, but I think there has been a lot of things happening in the meanwhile. So I would say it's a little less than Bluetooth, and there's also ways, like for example, what you do when you have a fold phone, then when the backlight is off, you also turn the NFC off. So there's also other means to reduce the power consumption. So it's difficult to make a fair comparison, but I can find out for you if you like.
Okay, yes, thank you. There's another question.
Yes, is the timing hard-coded and fixed, or is it adjustable?
It is adjustable. In fact, if you initialize your stack, the stack should have a means to adjust this. And also, what you can imagine is that you should have you should position this window here at random, because it could be that an external reader always tries to ping you when you are in this polling cycle and so on. So there should be some randomness included here.
Thank you.
Okay, let's go on. So the next use case is pretty similar to the first use case, but now some other communication media come into play. So here you have an active phone as a reader, then you have a tag device. In this case, for example, the printer, and the activity is that you would touch this device and read some local connectivity settings from an NDEF record, which in case of a Bluetooth tag on a printer would be the Bluetooth address and maybe the PIN. And then in the next step, some more powerful media would connect to this printer in order to perform the print. So I think this will become pretty popular for headsets. Once you have more NFC in phones, you could have a little NFC tag on your Bluetooth headset, and if you walk through the streets and people tap on their ears, you know that they create a connection to their mobile headset. And also the printer, I think, is a pretty good use case, and I think we would see a lot devices that would carry NFC tags when they are devices that you typically connect. Then there is this kind of new use case which is really device-based, which is peer-to-peer communication. So the actors are two phones in peer-to-peer mode. You remember peer-to-peer was also based on ISO 14443, so you would detect the other phone in the first slot, polling slot, and going up the stack you would discover it's not a MyFair, it's not Topaz, it is a peer-to-peer, and then you would create a peer-to-peer connection. And the typical scenario is that also in this case you make a negotiation between these devices about what kind of media use. So this device would say, I have Bluetooth and WLAN. And he said, well, I have Bluetooth and WLAN, but WLAN is not switched on. Then they say, okay, let's use Bluetooth. And then it would create a connection. You would transfer a picture or a music track. So can you imagine, why wouldn't you just transmit everything over NFC? Because it's very boring to hold the phones together with your friend for a minute or so. You know, the data rate is just at maximum 400 kilobits per second, and it can take quite a while. So this is the main interaction, like the most important interaction paradigm. In fact, a business card you could easily transmit via NFC, and I think it would still fit into this or still suit this kind of touch feeling. So the stack again in peer-to-peer looks like this. It's again based on ISO 14443. And then on top of that, there is another standard called NFC IP1, which is a pretty funny standard because you read it and it really looks like 14443 type 3, only that they changed all the definitions and all the acronyms. I don't know why they did, but it's really confusing. And on top of that, you have a protocol LLCP, which is the same as L2CAP in Bluetooth. So it's some logical link protocol, has some flow control, creates on top the illusion that there is a symmetric communication with the initiator and the target, which it is not. Then you have a protocol that you can put NDEF records, transmit NDEF records. So it's called SNAP, is I think simple NDEF encapsulation protocol or so. And then you have other bindings. For example, if you would like to transmit a business card over NFC, you would have here the OPEX protocol. Interestingly, when you can have transmission with 100 kilobits per second, but you can negotiate that you want to increase the speed, then it would kind of switch over to this protocol over here. Very difficult to show. Any questions? Okay. And then the next use case is really exciting because it's very different from all the other use cases. Because here now we change roles. The use case is phone acts as a smart tag. So this is the use case is called in technical terms tag emulation. what happens here is the phone is in this 300 millisecond polling mode or listening mode where it listens for an external field. And the reader comes close, and then this reader would directly connect through the NFC modem to some device that is called secure element. And that is nothing but a smart card. And the phone software is not necessarily noticing what is happening here. You can, in good NFC implementation that manage the power consumption carefully, you can even switch off your phone and you could use it for payment. So that means the host software is not even powered on. There's of course use for the host software. For example, you would like to know by an application that talks to the NFC, to the secure element through some other channel, well, what was my last transaction, or if it's a loyalty card, how many loyalty points I gained. And also like MasterCard or Visa, whenever you make a transaction, they would like, for example, to display a branding animation on the UI. Thank you for using Visa, because that's nothing they can do with their plastic cards. But it's a kind of a very interesting use case. And it's also so that when your battery runs low or your battery runs off, it is required that this works. But because imagine you go to the underground, to the metro station, like in Paris metro station where there's really gates, and while you're on the train, you're running out of battery, you don't get out of the train station anymore. Would be very nasty experience. You would probably get arrested when you jump over the gate. So what is a mobile wallet? A mobile wallet is something that needs to be used in context of your secure element. First of all, I think it's very interesting to zoom into this secure element itself. The secure element is some very sophisticated processing platform, and I give an example how a secure element would look like when it's implemented according to the global platform specifications. So it is a computing platform which has a secure operating system, a smart card operating system. On top of this smart card operating system, you have some card manager which does some housekeeping functions for all the applications that reside on this secure element. And you have different kind of security domains that are owned by service providers that have applications living in the security domains. And then you have one issuer security domain that belongs to the, let's say, landlord of this secure element that is renting the space out to all the service provider which want to have the application of this smart card. So when you think about writing software for NFC, and if you think about payment and ticketing, these kind of things are important application, like programming. So taking a look at secure elements and find out how to program a secure element is at least as interesting as programming on the host software of the mobile device itself. So basically, the charm in having a smart card that can connect to the internet, and basically that is an NFC-enabled phone, is that that you are not obliged to go through the classical smart card logistics that is like sending plastic cards to people and then have another letter sending some PIN codes and so on. But you could download your application on this smart card, and you could also remotely manage the life cycle of this activation. You can install them, you can personalize them. That makes them personalized to the actual user. You can enable them, you can disable them, you can display updates and all these kind of things, and all this on this little smart card. It's not really for knowing that there is a host software, that there is a display. So of course, you want to have also a host site representation of your application that you have in the wallet. Like this could be a credit card, this could be a loyalty card, and of course you want to have an application, an app on your phone that shows the user, well, yes, there's this application inside, and that can also give some information like how are my loyalty points, what is my balance, what are the past transactions that I did, and so on. So this is the purpose of the wallet. But not only this, somewhere on the wallet must also be an OTA, over-the-air client for the wallet management. That is the peer application of this issuer security domain, and this has to make sure that applications get installed on this secure element. And the chain for this is that typically you have application issuers that have an application that they want to have on the secure element, and then they, even though if let's say it is a UICC or a SIM card, then it would typically be enough if they would go, or the MNO could take the role and owning the issuer security domain, and then put on behalf of the application issuer the application on the secure element. But there may be very many MNOs, and the application provider doesn't want to make a commercial agreement with each of these operators. So typically there's a trusted service manager in between who has commercial agreements with many operators and who has commercial agreements with many of these application issuers and who manages it. And there's also several models. So we will talk about this later. So for example, if it is a bank A, it would not like to some banks, one always have to be careful what you say. Some banks would not like to have an operator between them and the end customer, because they have an end customer base themselves, and so do the operators. Also the operators have a billing system and could play banks themselves. So there's different ways or different models how this issuer security domain is managed. And on the one extreme side, it's managed by the MNO. There could be kind of a shared management, for example, that the MNO installs the application, but the trusted service manager personalizes them. And there's also models like where the secure element in the phone is not a SIM card, but is a secure smart card. Then you don't need any operator at all. Any questions?
Some question regarding security. If I use a smart card based EC card, I need a PIN code normally.
Yes.
Works this the same way? I have to put my phone on a desk and then to enter some PIN, for example, if it is.
It could work. It could work the same. So you could, of course, there's several models. First of all, you could have a PIN in the phone. That means if you slide your phone past a reader, then with a plastic card you cannot enter a PIN on the plastic card. You can enter it on the terminal. But with a phone, you could have a mechanism where you say, well, where the phone detects where somebody wants to read the secure element. First, let's activate it. So you give a PIN code inside the phone, then you slide it past the second time. Then having this EC card application, as you said, if this is going to be contactless and there's a PIN card required, why not entering the PIN card again into the terminal like with a plastic card? So that's basically not a difference.
So I don't need to be worried if I lost my phone, for example.
Yeah. Well, I would be worried. But no, okay, let's be serious. I don't think it's less secure. So I mean, 50% of all credit card transactions are done still today with Maxstripe. And if you are not worried about Maxstripe, don't be worried about this.
Okay.
Yes.
Oh, there's another question.
Are there also models where the communication between the OTA client and the application issuers go over the internet? For example, SSL encrypted or something, because then you wouldn't have the MNOs and the trusted service manager.
We will discuss the different options of secure elements, but one option to have a secure element is to put the secure element directly on the printed circuit board. The other one is to put it on an SD card. In fact, then you don't need any operator.
Okay.
But I think what we will see in the future is more and more SIM card based, because it just makes sense technically, and these guys just have to make agreements. And somebody said NFC stands for need for compromise. Okay. So where to put the secure element? So one option is to put the secure element on the SIM card. I think this makes sense because there is already a secure element in all of our phones, and it's already connected to some entity which can manage it. And if you trust this entity, there should be no problem to take the SIM card itself as a secure element. The other option is to put the secure element on the printed circuit board itself, or there's also kind of piggyback chips that have the NFC modem, and on top of that they have piggybacked a secure element. This option is, there's implementation out there. For example, the Nexus S has such a component, but it's a little bit, it has disadvantages. Like your credit card is then fixed and bound to the printed circuit board of the device. It's like you would kind of stitch your credit card to your wallet, and if your wallet is worn, you want to throw it away, you have to throw it away with your credit card. So that's why this option has probably not a great future. Then we have processors with a trusted zone, like the trusted ARM zone, but this is not really considered secure enough. But there have been discussions in the beginning whether this could also serve itself, because it's very inexpensive. It's just there. And then the final option is to put it on a secure card, on a secure digital card. This is technically a little bit more difficult than this one. And remember, like, operators are subsidizing phones, and when they buy a phone where the secure element is on a SD card, they would rather maybe subsidize a phone where the secure element is on the SIM card. Yes?
I'm very interested in the comparison between different type of secure elements regarding the cost and the management cost and security level. Are they at the same security level, and do they have similar management effort cost?
Okay, I can answer this question partly. So I think we can forget about this option, like the trusted ARM zone, because it has been rejected anyhow. Taking these two solutions, they are basically the same, because the smart card on this kind of thing is the same as the smart card on this kind of thing, and they're also talking the same protocols. I'm not very sure about the secure digital card, whether they have the same kind of smart card architecture also, like ISO 7816. If they have, then it's the same, but I'm not entirely sure.
For the developer, what type of a runtime do I expect to develop, for example, application for such?
A Java card runtime.
Okay.
So Java card is a very stripped down dialect of Java. So I think you don't have any more. I don't know it well, but you don't have any more dynamic memory development, no garbage collection, this kind of thing. It's a very primitive type of Java.
Thank you.
Anyone else? Okay. So implementations that are out there. So there's Google Wallet, and Google so you always have to have a consortium. It doesn't help if you come out with a phone. Typically, you have to have an agreement with a bank, and this bank or an issuing bank, and then the credit card system, and an operator. And Google Wallet went live with Citi, Mastercard, and Sprint, and I believe Google Wallet is already in operation, at least in the US. I don't know, has anybody of you experience with Google Wallet? Has anybody ever tried to download and work with it? Okay. Another, I think the second notable activity, I think there may be more out, but this is one I know, is ISIS in the US. ISIS mobile wallet, and the founders are three operators: Verizon, T-Mobile, AT&T. And the cards that are supported is first the ISIS cash card, but there's also discussions as Barclaycard, Discover card, which is a popular credit card over in the US, Visa, MasterCard, and Amex, and they started a pilot in Austin and Salt Lake City. Okay, so any
Excuse
more?
me?
Yes?
Are there any expectations for Germany? Which kind of mobile payment system will arrive here soon or later?
I have to confess I should be better informed about that. I hope that ISIS, once it is introduced in the US, will also swap over to Europe, and I don't see any reason why Google shouldn't make, if this is really taking off, shouldn't also make agreement with European banks and credit card providers.
Thank you.
Okay, so now I believe many of you are really active programmers and software developers. You may be interested, so if you want to do something with NFC, how do you start? And one great method to start is to go to opennfc.org and download the OpenNFC development environment. OpenNFC is basically put into life by Inside Secure. Inside Secure is a French-based company, and they also do NFC modems, and NFC modems combined with secure elements and also secure elements. And they have been creating a full-fledged NFC stack, and they published it and also published it with a complete development environment. So the architecture and how OpenNFC works is that you have an NFC server, and you can have several clients connecting and registering for events in this NFC server, and they support on Linux and Windows. So on Linux operating environment, the clients connect over socket to this NFC server, and in Windows over I/O control. And the NFC server is built on a so-called hardware abstraction layer, and depending on what kind of hardware you have below, you have to adapt this hardware abstraction layer, and you would get one implementation of a hardware abstraction layer for the OpenNFC evaluation board. So if you really want to have the hardware and play with the real stuff, but you can also have a simulator hull. And so regardless of whether you connect the simulator or whether you connect the real evaluation board, you go through this connection center, which can reside, for example, on the same PC if it's a Windows, or on a second or on a different PC, but this runs only on the Win32. And this connection center, depending on what hull you have, would connect to a simulator or would connect to the real hardware. And this is some kind of an grown-up simulation and environment. You can simulate with it. It's not only for tag read write. For example, you can start another instance of the server and connect this server also to the connection center, and then also simulate peer-to-peer connections between two virtual devices. And yes?
Okay.
So did I just get that right, that you actually have to have at least one Windows machine to make it work for the connection center?
Yes, the connection center, you need a Windows
no,
machine.
that can't be true.
Yeah, it is.
Okay.
Yeah, I hope I'm not telling. I think it's true. Wait, please check the opennfc.org. But I have not worked with the simulator myself. But I was taught by a colleague who works a lot with this environment. He said, yeah, this one runs only down Win32. That's why I put it here. Yeah, it's frustrating for Linux users, but. That is an interesting discussion for the buffet. Okay, so a little code snippet of OpenNFC. It's not really surprising. So what you do, it's event-driven. So you have a callback with a callback function with this signature. Then you have a main function. you register this register this callback with the function ndef register message handler. So you have this message here, you register it here, then you pass along some parameters like the priority, which ndef, what kind of ndef records you want to see, only well-known ndef records, not kind of privately, proprietarily cooked up. And here you have well-known, and you only want to see URLs. And that's it. So you have registered your callback, and then you wait until something happens. And if you don't want anymore, you just close the handle and terminate. And then the callback function is not really a surprise. So you this is the callback function. So you get a handle of the record by calling the function getRecord. The handle is returned, and then you take this handle and pass it on to a function that gets the value of the ndef record that is associated with this handle, and it stores it in this variable, and then you can print it out. So NFC is a confusing technology, but on top of the stack inside the operating environment, it can be very simple. In Android, it works with activities and with intents. So you register for an intent, and there's a couple of level of intents that you can have. One intent is you can register to that you only want to see ndef types of tags. Then another level down is you want to have, let's say, only a particular technology like MiFi ultralight. And then another intent is, you want to see anything that's coming up. And if you don't have an NFC phone, you can also take this fake tags activity, which generates you fake events as if they would come from the NFC, so that you can play with it. Please don't ask any questions, because I'm not an Android developer. Yes?
No, not about the Android part, about the, I think it was C++, the code.
No, the other code, I think this was plain C.
Plain C. So where would the code run if it would be a production environment? Would it run on the receiver side, or would it run on a microchip or something?
It would run on the host processor. It would not run in the modem. Not in the firmware of the modem. It would really run in the host processor.
Ah, okay.
Okay. Okay. So some implementation. So
there's another question.
Yes.
Excuse me.
You didn't mention libNFC, the open source implementation of NFC. It's not OpenNFC, it's libNFC.
This libNFC, basically, when you write a client, then you use the ONFC lib. This is where all the NFC stuff happens. So the client is your code, and this is the library that you use.
Okay.
It's from OpenNFC. That's why it's called ONFC user lib.
Okay. Because there's the libNFC, is it the same, or?
libNFC is.
It is a project which has some libraries. You can do everything with it, even peer-to-peer. And it's really simple. It's plain C, and you can buy dongles, the NFC dongle for 20 or 30 bucks, and then you can play around with it.
Is it a full NFC stack? Is it a full NFC? Or
more or less.
And for which platforms?
For different ones, it's the PN51.
Yeah, okay. Then then this is probably coming from the so-called FRI. Then it's maybe the libNFC from NXP, because there's two competing stacks. The one is from NXP, and the other one is from Inside Contactless and Inside Secure, and they are not fully compatible. So, for example, Google adopted the stack from NXP, and in a way they also were then locked in, at least partly, to the NXP chip, because you have to do some tricks to really. It's possible, but it's not straightforward to make, for example, the NXP stack work on, for example, Inside Secure radio and vice versa. It's possible, but you have to know what you do. It's just work. But they are not. You say, like in Bluetooth, you have the host controller interface, and in theory, you can take any Bluetooth radio, and you have the standard HCI, and then every stack would run with any component, and there's really just little work to do. And I think NFC is getting there, but it's not there yet.
I got another question. Is there any handset vendor who plan to adopt this open NFC stack? Is there any
yes, but
potential?
There is, but I cannot disclose it.
Okay.
Yes, there is, in fact.
Okay.
These people are working for money. They would be, of course, they have customers.
What's the differentiate features
between you mean NXP and Inside Secure? I have personally not compared the stacks, but I was told that there's little difference for the end user. Maybe here and there little difference in the power consumption or performance and powered by the field if the battery is low and these kind of things. But I believe that both are fit for purpose.
Okay.
Okay. So far this Android. Yeah, some implementation. So this is the Nokia C7. So the Nokia C7, it has here the antenna is always on the top, like on the top of the display. So when you touch two phones, then like intuitively you would probably do it right. Sometimes you also see antennas being wound around here. Then it contains the NXP 544. Which is the pure modem without the secure element connected to it, and it is in fact, like from hardware-wise, connected to the UICC, but Nokia so far never released a firmware which kind of puts this link into action. So I don't know any more details, but that's a matter of fact. Then the next is the Google Nexus S. Very interestingly, the Google Nexus S. Okay, that's not a surprise because they took NXP stacks, so it runs smoothly, of course, with the NXP chips. The PN65N is basically a piggyback chip. It has the modem and then the secure element on top. So it has all the advantages and disadvantages having the secure element firmly connected to the phone itself. Yeah, before we come to the philosophical part, any technical questions?
Yes, there is one question.
Do you possibly know of any more phones which are to come in the next years who also have or will have NFC?
Yeah, I know a few, but this is also customer intelligence. I cannot tell.
Okay.
Sorry.
Okay.
Yeah. Yeah.
I think the Samsung Galaxy S3 is supporting NFC.
Okay. Okay.
And it's coming next month.
It has been launched. Okay, that's good to know.
Yeah.
Okay. Do you know of any good comparison resource with source code?
Okay, over there. You mean source code?
A comparison resource like a book which puts it all together in an application?
I'm not sure I get what you want to say. Maybe you can also...
I want two things. I want to get a book of the definition.
A book of the definition?
Yes.
Of NFC?
Of NFC and code snippets that I don't have to start.
Yes, of course. So you get a lot of code snippets in OpenNFC. And OpenNFC publishes a lot of example code. And also in Android, in the developer forum, you see a lot of example code. And there's also a good book about NFC, but the example code is in J2ME, and I don't know whether this is you want to put your fingers into that. Okay, so this is a very interesting curve that Gartner, it's an analyst, they are publishing it every year. So this is the Gartner's hype cycle of the year 2011. And on the y-axis you have kind of consumer and business expectations, and here you have the time. And what they say is that every technology is kind of moving on this highway, just some technologies, they move faster, some slower, and some break down in between. So it starts with a technology trigger, then everybody is happy and excited, and then they have the technology is fit for saving the world, and then they find out it cannot save the world, and then it's going into a valley of despair. And then all of a sudden they say it was not all that bad that we invented, and then it takes up, and then it's commoditized, and in the end it's here, but it's not kind of meeting the initial expectations. And interestingly, in 2011, maybe even before, you find NFC payment exactly here, so on the peak of inflated expectations. And interestingly is, I think there's some of the technologies really go through in a couple of years, but if you think that the whole thing started 2003, now we have 2012, it has been really going up in a very, very low speed. I mean, it's debatable. Probably they are already here, and I think there's also some people that say, well, it will never take up. But okay, that's where Gartner put it. So NFC is advertised, and an NFC payment for a very long time. So what is really the reason why everybody intuitively understands it's an important, cool technology and something they need, but we never kind of made it work until now? Some people say it's an acceptance problem, and that's why big institutions have not been investing. And it's very interesting to take a look at, we have been just discussing it a couple of minutes ago, to see how payment instruments are kind of penetrating the payment market. So if 100% is the overall transactions of our credit cards, we see that EMV type cards that have this chip, so contact card that obey to the specifications of EMV Co, have only 40% of all transactions, and contactless has only 9% of all transactions. And the question is then, well, this is similar payment instrument. If there's something very new coming, and people are very careful where they make their payments with, and then there's also bad advertisement about eavesdropping and so on, would they ever pay with a phone? I think this is a valid concern, but I'm not really impressed by this argument, because the end customer is not really, I think for him it doesn't play any role what kind of card he has, unless it's compatible with the terminal in the store what he has. And most cards will probably have, in the end, and even contactless cards have in most cases an EMV chip and probably even a MAC stripe. So it's not the end customer. Then the merchant, for the merchant, of course, it's an investment, but it's not all that great. So it's an argument, but it's true, but I think it's not the main concern. And it's really more interesting to look what happened with NFC over all the years. So this is a forecast of NFC taking off, and the interesting thing is to look when it has been made, and it has been made by iSupply. It's one of the biggest analysts in that field in 2011. 2011 is here. So I have not found the same graph with a forecast in 2007, but if I see like 2008, and some analysts would have made a prediction, it would go exponentially here. So this graph has been always pushed into the future all the time. While I have to admit, of course, and I really hope that there's a change, that now Galaxy S is coming, we have Nexus S, and we have the C7, that really something is happening, and Google has the wallet, and ICE is coming up. But it's very interesting to see what happened in Japan. Felica Networks also started in 2004, but in 2009 they already had 50 million Felica phones out there only in Japan, 50 million. And see, the scale here is something like 600,000, not even 1 million. So this would really go over the roof. And in end of 2011, they had 70 million Felica phones, and 10 million of these Android phones. And so that means it's basically the same use cases. So I think this is a solid proof that there is really customer demand, and something that is useful for the customer will finally make its way into the market. Let's see what is the difference between NFC and Felica. Both started in 2004. Felica is mostly concentrated on Japan. There's applications also elsewhere in Asia, and a few applications also in Western countries. Felica is basically based on one dominant spec, which is this one, and NFC, they wanted to be everybody darling. So they had a lot of two major specifications, and then this NFC IP1. Then the secure element in Felica just proprietary, so it's an industry standard. No need to negotiate with anybody, but maybe not a decision. I think this is not hampered. I think this is a solid standard, so I cannot say that anything was hampered due to this decision. Tags are only by Sony. In NFC, many tags. Then secure infrastructure, you can license it from Felica networks. And from NFC, you have at least two big parties, even more, like at least inside Secure and NXP, but there's other people out there like SCC, Broadcom, and so on. Then investors and decision makers. Well, in Felica Forum, you saw it was, as an operator, was Docomo, the operator. It was JRE, which is a service provider for ticketing. It was Sony as a semiconductor. So you had the right three people in one consortium. So they could basically do what they want. Of course, for their payment stuff, they need to have banks. So they work with Mitsubishi. They work with Visa. But I mean, most of the stuff can just be decided within their own four walls. And again, in NFC, many people. Technology owners, Felica networks, many. You see Innovision, NXP, and so on. And well, this seems to be the secret for their success, because they have 70 million devices, and just to term it positively, we are slowly getting there. I'm confident we get there, but you see from this comparison what was the real reason. Also reviewed like the technology compromises. Felica, everything like made from scratch. This is like a recipe for success if you want to kind of go through this lane of the Gartner's hype curve. If you have a new technology, you do research and validation, but you wait with product development until you do proper standardization and IPR policy. I think it was Nokia and Ericsson that were the main contributors to Bluetooth. They made some prototypes, then they teamed up, and then also with some others. And then that is very important, then they created an IPR policy which said that whoever is in the Bluetooth club will never take license fees from other people for the patents that he would put into the Bluetooth patent pool. And after that, there was product development. I think this was very, very, very successful, and also very monolithic specification, a very good specification, and everything makes sense what you have in this specification. It was really done from scratch. In NFC, this is like recipe for disaster. You do research validation, you do a lot of product development, a lot of proprietary solutions, and later on you standardize it, and that is where all the compromises come in. But I'm not saying, I think the technical compromise, I think we have been pretty good, because we have seen working implementations already pretty soon. I think the worst problems came in the ecosystem. So let's check what is a robust business ecosystem. A robust business ecosystem is, for example, is where you have a value chain that is populated by players from different industries and that have different skills and interests. And when you have competition, the competition stays within the same industry. Take like the simplistic case, you have kind of a chain of production, logistics, and sales. Somebody is producing something, somebody is carrying the products to retail, and somebody is selling it. So the logistics party, like the forwarding company, would not kind of have the idea to produce the stuff and get in competition with this guy. And he would also not sell the stuff that it has on the truck before it gets to the sale. So but there is competition between different companies, and they compete for their business. Let's take a look how it is in NFC. So this is what I would call a volatile ecosystem. You have overlapping skills and interests, and they could result in paralysis and fragmentation while you establish your business model. This is also very, very simplistic model, but take the credit card issuer, who needs to have the operator between him and the end customer, who would have a phone with a USCC with a SIM card as a secure element. Of course, you could make a setup with a trusted service management and so on, but in the end, the credit card issuer would not feel comfortable having always the operator, or at least partly the operator between him and the end customer, because both of them have end customer relationships, and in theory both could compete for the same customer with the same service. So why shouldn't the operator offer payment or banking services to the end customer? So a way to get around this would be that the credit card issuer would go through a trusted service manager directly to a user which has phones which with a secure element running on the PCB or running on the secure digital card, so that when the trusted service manager would not compete with the credit card issuer because it doesn't have a direct relationship to the end customer. But this is also difficult because the operators are handset makers' best customers because they subsidize it. So they would rather subsidize a phone which has the SIM card, the secure element on the SIM card, and not this one. So there's lots of business models and simply too much choice, and there's technical solutions that favor one or the other business model that is in favor of one or the other player in this ecosystem. Any questions or comments to this? Oh, then we are already at the end. A short summary. So NFC, I think that has become clear, is a subset of RFID standards selected and complemented by the NFC Forum. NFC simplifies user experience for many use cases, and it will change the way we will perceive our wallet. Right? And third point I would say is NFC rollout we've seen is difficult, but we will finally succeed because we've seen in other markets that NFC is an interesting technology and that end customers want it. And what we also seen that beyond payment, there's lots of many cool applications we can do with NFC because it supports this very nice and gentle user interaction paradigm that you touch something with your phone and invoke an action. And I think finally, I believe that even NFC is so long out there, most of the stuff has not been invented yet. And I think there's a lot of cool applications that you can write, and a lot of inventions that can be done. And I think we will see the peak of kind of creativity invention when NFC is really rolled out in large scale. Ready for dinner? Any questions?
Could you give us examples of any insecurities concerning the NFC technology?
Oh yes. You know, NFC is not a single technology. There's many technologies, and I think a must view for everybody of you is the video of these two guys that hacked in 2009 the Mehr Classic, which was supposed to be very safe, and they did it with a microscope, and I don't know the English word, in a Schleifmaschine. They reverse engineered the algorithm and they hacked it. And this was very bad because 90% of all, I think, NFC stuff, I don't know whether it's 90%, a considerable part was done with Mehr Classic. And NXP had immediately to come up with some kind of safer solution, but all that stuff was out there. So that is one prominent case of security breach in NFC. Basically, it's not NFC because Mehr Classic is not part of the one of the four. But of course, you can do a lot of mischief. I cannot say whether NFC is insecure, but of course you can tap communication. You have a smart poster where you can kind of tier one tag off and put your own tag there. It leads people to other web pages and let them make payments there. So there's a lot of stuff that you can do. Or a relay attack, like you have a phone which has its credit card enabled, and then you put kind of a relay transmitter close to the wallet that transmits it to somebody else who has its kind of proxy terminal in front of a reader. But I think it's not less safe than a credit card because you can always enable it, disable it. You can have another PIN mechanism on the phone itself. So I think it's It's pretty safe. For payments, if it uses smart cards.
Okay, but physically it's easier to interfere with an NFC device than to actually interfere with a credit card, because you have to put your credit card into a slot, into a reading device, and the NFC device is just laying on top. And imagine a skimming attack, or you are at a reader and there's an antenna looped around the reader, and you actually can't see it because it's very thin.
Yeah,
I think physically it's easier to interfere with NFC.
Yeah, I think physically it's you don't have an electric contact. You have a contactless card, so you can put something in between. But I think what's important is that you have a strong end-to-end encryption, and I think this is all triple DES and so on. So, but of course, I mean, you are the experts. I should ask you.
Okay, thank you.
Okay, there's another question.
But every time you have an end-to-end encryption and you decode the chip simply with a microscope, then it's open.
I think that's not that easy with. So that was MyFair Classic, and MyFair Classic, I think they had a kind of fixed custom logic, while contactless smart cards they run a program. So you would see the ALU and these kind of things, but nothing that would really help you.
So I need the program. I will need the program.
Yeah, you will need the program. But I think I hope they learned. But I believe that of course everything is possible, but I think it's much harder to reverse engineer it.
I think MyFair Classic problem was that it was classic.
Can you put it more to your mouth, please?
It was a classic example for security by obscurity.
Yeah, exactly.
And
I mean that
it's not the case with NFC, I guess.
No, that's not the case. So they work with. I'm not sure whether some stuff I'm not sure what parts of EMC are open source and public, but they work with the classical like AES, triple DES algorithms and so on.
Okay. Are there any other questions? No? Okay. So let me say thank you for your nice presentation this evening.
No.
I also want to say thank you to the Seabase and all of you who come here this evening. We will have an introduction through the station in half an hour, 9:15. You will meet there at the gate where next to the automat. And thank you very much for coming. One last good message I have is last time we had a tech talk here with the guy from Microsoft who showed us how to work with a Microsoft Kinect, and he was able to get an example for the Seabase. So thank you very much, Daniel Meixner. And I think that's worth an applause. Okay, so let's have the hot dogs, and if anyone likes vegetarian food more than sausages, take the stuff with flags. Yeah, that was the word. Yeah, thank you very much for coming, and see you there at the buffet.